Welcome back to the Solutions Manual. In this video, we will solve the problem 3-26 from RC Hibbeler Engineering Statics 14th edition. According to this problem, the 30 kilogram pipe is supported at A by a system of 5 cords. We have to determine the force in each cord for equilibrium. So to solve this problem, first of all, we will draw the free body diagram of point A. The free body diagram of the point A would look something like this. This is the point A. So we have a tensile force in a downward direction. We have a tensile force to the right. And we have a tensile force at an angle of 60 degrees. Let's label them. So this right here is TAE. This is TAH. And this is TAB. This angle is 60 degrees. And now we have to resolve this TAB force into its components. So we have a vertical component and the horizontal component. Let's label them as well. So the vertical component is TAB into sine 60 and the horizontal component is TAB cos 60. Let me zoom in. So this is our free body diagram for point A. We know that the cord AH is supporting the load. So the tensile force AH is equal to the weight of the cylinder. So 30 into 9.81. So TAH is equals to 294.3 newtons. This is our first answer. Now we can apply our equations of equilibrium. So my first equation would be summation of forces in y direction equals to 0. I am considering up direction as positive. So we have TAB sine 60 minus TAH equals to 0. So TAB is equals to TAH, which is 294.3 over sine 60. So TAB comes out to be 339.8 newtons. So this is our second answer. Now we have to find the force TAE. For that, I am going to do summation of forces in x direction equals to 0. I am considering right hand side as positive. So we have TAE minus TAB cos 60 equals to 0. So TAE is equals to TAB cos 60 and TAB is 339.8 newtons into cos 60 comes out to be 169.9 newtons. So this is our third answer. Now for the rest of the forces, we have to consider the free body diagram of point B. So the free body diagram of point B would look something like this. We have a tensile force TBC and we have the tensile force TAB. Let's label them first. So this right here is TBD, this is TAB, and this is TBC. If this angle is 60 degrees, it means if I draw a horizontal here, that angle also has to be 60 degrees because they are alternate angles, so they are equal. So this angle is 60 degrees. This is the x-axis, that is the negative x-axis. This is the positive y-axis and that's the negative y-axis. So now we have to resolve the forces TAB and TBD into their components. So for the force TAB, we have a vertical component and the horizontal component. And for the force TBD, we have a vertical component and the horizontal component. Let's label them. So the vertical component of TAB force is TAB sin 60 and the horizontal component is TAB cos 60. Similarly, for the TBD force, we have to consider this 3, 4, 5 triangle. Let me zoom in. This 3, 4, 5 triangle. So the vertical component of the TBD force is TBD into the ratio of 3 upon 5 and the horizontal component is TBD into the ratio of 4 upon 5. So this is the free body diagram of the point B. Now we can apply our equations of equilibrium. So my first equation is summation of forces in y direction equals to 0. I am considering up direction as positive. So we have TBD into 3 upon 5 minus TAB into sin 60 equals to 0. So TBD is equals to TAB into sin 60 over 3 upon 5 is 0.6. So dividing it by 0.6, and we know that TAB is equals to 339.8 newtons, 339.8 into sin 60 over 0.6. So TBD comes out to be 492.7 newtons. So this is our fourth answer. Now we have to find the force in one more chord, which is the chord TBC. For that, we are going to do summation of forces in x direction equals to 0. I'm considering right hand side as positive. So we have TBD into 4 upon 5 minus TBC plus TAB cos 60 equals to 0. So if we substitute the known values, for example, TBD is 492.7 newtons into 4 upon 5, which is 0.8 minus TBC plus TAB, and TAB is 339.8 newtons into cos 60, which is 0.5, equals to 0. So upon simplification, TBC comes out to be 564.06 newtons. This is our fifth answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts in the free body diagrams or in the equations of equilibrium, then feel free to ask in the comment section and I will try to answer them as soon as possible. Thank you.